Good morning. My name is Piers and I'm a data scientist, and I can't see anybody out there, so this is going to be fun. Hopefully you can see me. As I say, I'm a data scientist and I haven't quite invented time travel yet, so those of you that have spotted 2017, that might be a quiz question later, you can decide. So it's an absolute pleasure to be here this morning. Great to open the conference, and it looks an absolutely amazing venue, something I've never seen before here today. And what I wanted to talk to you about was data science, quite generally, but some of the questions that we get asked. So if I can kind of get a show of hands, how many data scientists have we got in the audience today? Got a few, okay. So one of the questions that I get asked most frequently is, you're a what? You're a data scientist. And that comes from both customers that we deal with in the public and private sector, but more frequently it starts coming in from people that I work with. Okay, so Kainos is a great engineering company, but the question is, what exactly is it you guys do? You're a data scientist, what does that do? And it's difficult, because it's difficult to try and explain to people the difference between a data scientist, a machine learning engineer, a data engineer, all of these kind of new terms that are floating around. So what I'm going to try to do this morning is walk through how we think about it, how we ended up being called data scientists, what it is we really do, and how Kainos views a data scientist and the work that we do. So Josh Willis was really helpful back in 2012 when he coined this lovely tweet, and he said that it's a person who's better at statistics than a software engineer and better at software engineering than a statistician, right? Well, I'm going to confess that I'm pretty crap at both of those things, to be brutally honest, so that didn't really work for me. So when I'm trying to explain what a data scientist is, I'm looking for a different kind of answer, a different kind of solution, and none of these two really fit either. I don't really like either of these two. So, you know, I'm not in San Francisco, I work out of Belfast, I spend a lot of time in the UK, I work here in Gdansk on occasions and throughout Europe, so these things don't really hold true for me either. So I think what you've got to do is you've got to go back to the beginning, and you say, this isn't really a new thing, it's a new term for a lot of things. So that's a very busy diagram, but what it does is it brings together the various strands from computer science, technology, mathematics and statistics that have been woven together to allow us to get to the stage that we're at today of this idea of data science, and how they all bring new technologies and little bits and pieces of their backgrounds into what is now today called data science. So those of you that have a bit of a maths or a stats background will have definitely heard of Bayes' theorem, you'll have heard of probability and all of those kind of things. Not new. Those of you who are playing with TensorFlow at the moment, perhaps, will be using neural networks. Again, that's not a new thing. 1947, thereabouts, is when neural networks started to appear. So what we're talking about here is a change. What's made these things today suddenly popular? And that's where the technology and the compute power that we now see coming through and the data storage technology that we have makes all of this possible. So I'm sure you've seen something like this before. All right? Here we have the three key areas, according to all the learned people in data science, that makes up a data scientist. You need a little bit of computer science, you need some maths and stats, you need to have domain expertise. And if you put all of these things together, you get your unicorn in the middle, the person that knows everything about building widgets in a factory, the person that knows everything that they need to know about Python or Scala or R, whatever it might be, and person who's got really good maths and stats background. And that's where you then see those feeding back in from engineering, research, and machine learning. Problem is, you end up with this, right? You end up with some wildcat unicorn riding through, delivering value everywhere they go and creating magic, right? And that's a problem that we face. People say to us, all you need is a data scientist. Go and get yourself a data scientist and all your problems will be gone, right? They will take your data sets, which are probably in silos somewhere, they'll join them all together for you, and then magic will pop out the other end. And your problem will be solved, your business will be better off, and you'll get new customer bases. Everything will be perfect. Well, it just doesn't happen, right? I'm reminded of an adage that somebody mentioned to me recently, and if you cast your minds back to when you were teenagers, right, and there might be a few teenagers in the audience today, and think about how people used to think about sex when you were a teenager, right? Everybody was talking about it, everybody thought everybody else was doing it, and in reality, nobody really was, and those that were doing it were actually doing it pretty badly, okay? So it's a little bit like data science today, okay? It's the key thing, it's the key buzzword that everybody's got to have. So, here's our modern data scientist, and those 10 or 12 people that put their hands up earlier on, see if you can tick as many of these off as you can. Because we need the maths and stats, we need the domain knowledge, we need the database and the programming skills. But more importantly today, we're starting to need the storytelling skills, the visualization and the communication skills. Because what we're about as data scientists is not delivering models. That sounds like a strange thing to say. What we're about is trying to deliver and explain how those models can impact whatever organization or business it is that you're working in. So for me as a data scientist and somebody that recruits data scientists, I want people that can tell stories. We need people that can understand the maths and the programming that goes with it, but are able to communicate and understand what's the business problem they're approaching, right? Where is the problem that they're having? So why has it become such a big issue? Why am I here today, and why are you guys here today, and why are we talking about data and data science in particular, right? Because companies today are in a difficult position, right? It's a very connected world, it's a very competitive world, and they need to be in a position to transform their business to provide them with the tools that they need to keep the existing customers, because retaining customers is cheaper than getting new customers. It's about providing better and faster services to that customer base or to the citizens if it's a government service. And to do that, the only thing that they have available to them is their most important asset, the data that they've been collecting. So if you think about the data that you've left behind just on your way here this morning, Google Maps was our savior on the way here this morning, but it only got us as far as the outside of the building, and we got to walk around and around a few times trying to find our way in. But we're all leaving a massive data footprint across all the services that we're using. And as a data scientist, we want to help organizations extract the maximum value that they can get to. But the key thing is, we want to help them identify new things, right? That's where the money is, right? So if we look at this lovely graph, all Kainos graphs go up and to the right. So this one does exactly the same. But the key saving is not necessarily in developing new business models and new ways of doing things. Because the majority of customers that we talk to, and perhaps some of you in the room here, are not in a position to be thinking about new business models. You want to be able to revolutionize what you do and transform what you do, whether that's from your internal operations, whether it's unlocking the value of the data that's inside your organization, breaking it out of those silos, and being able to report and get some insight from that, or whether it's about changing the way in which you actually produce data. So we need a process, right? And probably you'll have seen this as well, hopefully, the crisp data mining approach. So it's the process through which we do data science, essentially. And what we can see is that we need to start in this diagram with business understanding. Well, that's not quite right, in my opinion. Because what do you think the key thing is that you need when you start a data science project? Does anybody have an idea? Can anybody shout out what they think might be the answer? No? What are you trying to do? What's the point of a data science project? You've got to start with a question, right? If you don't start with the question for any sort of data science project, then you're essentially doing theoretical research. You're on a fishing expedition. You're trying to find out what might be in a data set, what you might be able to do with it. And that's fine. But typically you want to start with a question. I want to retain my existing customers. So in telecoms, it might be the typical old-fashioned churn model. It might be a case of saying, I want to attract new customers. Who should I be selling this particular product to? So the old kind of market basket analysis and upselling problems that you face. But you want to start with a question, you then want to move through and try to understand the business, right? And typically, again, that's the challenge. For a data scientist, going into an organization that you don't know and you don't understand and trying to work through how their data is organized, what their data means, are all the key questions and challenges that you face. The data is the easy bit, right? We all love data. If we didn't like data, we wouldn't be in this room today. So that's quite simple and straightforward. We can understand the schemas, we know how it's structured, we know where it's stored, and we know how we can bring it together. But bringing the business context to it is probably the greatest challenge. Once we've done that, it's quite simple, right? We do through data preparation, we do some feature engineering, we do some summary stats and those kind of things, and then we'll get into the model build. And the piece that surprises most people is that the model build is actually probably the quickest and easiest piece of the entire process. And then we've got to do evaluation, right? So we've got to decide, is this model doing what I wanted to do? Is the performance where it needs to be? Is there some way in which I can tune this model? And we go back through and iterate across this kind of process. ultimately, we hope to get to deployment, right? But we might find that what we've built isn't really what the customer was after. It throws up new questions and we go off on a different tangent. But there is a process, right? So we're going to come back to that a little bit later, but this process is what really starts to set aside science from perhaps the engineering piece that we think of with data. Right? So taking that into mind, we can think of data science as being a concept to unify statistics, data analysis, and their related methods in order to understand and analyze a particular phenomenon that we're looking at. And it doesn't matter what it is. So you may or may not agree with that description, but I think it's fairly accurate in terms of what it is we want to try and do. That brings us back to where we're going to, right? So our domain expertise, our computer science and our maths and stats. How do we take this forward, right? Because everything that we saw in the beginning went from the 1800s through until 2010. What are we going to do next is the question. And my view on this is that we're going to start democratizing insight. We're going to start democratizing data science. We're going to push that data science further up the value chain, essentially. So we're going to make it more available to people. At the minute, you still have to go out and get yourself some data scientists, some people that understand how to model or at least understand how the tools should work. Right? But we're going to make that more flexible and more available to the masses. And people like AWS and Azure are starting to do that now. So what does that lead us to? Why do we need it? Right? That leads us to the idea of doing the Internet of Things. Right? We all have multiple connected devices today. And what we're seeing is that the value of this and the value creation is really coming from putting together the big data sets that we've got and the analytics together with those sensors and the different technology that we have and mashing those together, and that gives us the value that we're looking for. Okay? Now, what opportunities does that give us? Gives us quite a few. So these are just a few that kind of trip off the top of the head. And if you look at precision retail, for example, precision marketing, smart cities, these are all topics that we're starting to hear more and more about. Predictive law enforcement is an interesting one, something that I've worked in the past in London. But all of these start to have some sort of ethical questions built into them, right? We start to think about smart health and early diagnosis. We start to look at how we might profile people, whether it's at a border, whether it's for a particular crime. When we think about personalized finance and starting to take more and more data about how you manage your funds and how you work forward with those kind of issues, ethics starts to creep in. My colleague Bill Wilson will be talking a little bit later on today about ethics and data and how that's a challenging but very interesting area to work through at the minute. So where does that leave us? It leaves us going through this analytical maturity model. Right? It leaves us trying to move from hindsight and understanding what happened in the past right the way forward to what is roughly termed right sight at the moment, which is trying to understand what questions you should ask of the data and how you take that and make it more cognitive. But the problem is, we find that most people and a lot of the organizations that we talk to aren't actually on this maturity curve yet. They've dropped off the left. They're not even using descriptive statistics yet. They're not looking at descriptive analytics. They're not understanding what has happened in their organization because they face challenges with accessing their data and being able to understand what their data might be able to tell them. So how do we move people from the left to definitely the predictive and potentially the prescriptive side of things? Well, the problem that we've got is that many people don't quite trust what data science produces. Right? There's a couple of quotes up here. And it says that you can interrogate the data and you can basically get it to say whatever you want it to say. And some of you may have heard the quote from Benjamin Disraeli a number of years ago, and it was quoted by Mark Twain, I think, that said there are three kinds of lies. Lies, damn lies, and statistics. And I think if he was alive today, we'd probably add a data science in at the end of that. Because there is a lot discussion and concern around how good and how accurate we're doing things. And this is where the science question comes in. Are we actually doing science? Are we doing science the way that we should be doing it? And the key thing for me is that science is a way of thinking. That's why we have that process. That's why we have CRISP-DM. We have a couple of different versions of that floating around. Microsoft have just published their latest thinking around what the process should look like. And it doesn't matter what tools you're using. It's more around the fact of making sure that you're using a process. Are you actually thinking in a scientific way? Because if we look at medicine as a field, for example, you can see that medicine has many different flavors. So a psychologist perhaps is not the same as a surgeon, right? But they both have processes that they work through. Is one less or more scientific than another? No, they're not. So, to my mind, the process is what makes data science actually a science. And the key thing is that it's not just about data scientists. A few of you put your hands up at the very beginning in the room and said, yeah, I'm a data scientist, and I'm guessing the rest of you are engineers, machine learning engineers, or whatever the flavor or label is that you want to give yourself. But in Kainos, we think about it as a team sport. Right? It's impossible for us to do all the pieces in that process with just a data scientist. We need the complementary skills. We need to create a unicorn through a team. Individuals that are sitting in one-offs in a room darkened somewhere. So we use the business analysts to help us understand what the business is doing. We use data analysts to help us understand the data that's available to us. We use application developers to actually implement the code that we've created and the models that we're putting together. We use data engineers to help us get data from A to B and build the pipeline that provides the insight data that we need. And we use visualization experts and performance analysts to help us communicate that out. And the data scientist is a small part of that, small but crucial. Okay? So, to go back to the topic of today's talk, yeah, it is a science. You may agree, you may disagree, you may want to call it engineering. The key thing is it doesn't really matter what you want to call it, as long as you're following some sort of defined process about how you're actually doing the work. And that's me. Thank you very much. It's been a pleasure talking to you this morning.